Today we're going to be talking about translations. So first let's talk about, let's just say what a translation is. A translation is moving parts of our graph from one point to another. And to talk about our translations, first thing we're going to talk about is a vector. Okay? A vector is a quantity that it has both direction and magnitude. So it tells us not only what direction to go in, but also how far. That's what they mean by magnitude. And it is represented in the coordinate plane by an arrow drawn from one point to another. So this P to Q represents a vector. It has a direction, and it also has a magnitude. It has a specific distance that it goes. The initial point or starting point of the vector is P, and the terminal point, the ending point, is Q. The vector is named PQ. Notice the way they draw it with a line and then just a little bit of a half arrow right there at the end. Okay, that's how we designate something as a vector, which is read vector PQ. The horizontal component of the vector PQ is 5. So notice how it goes 5 to the right. And the vertical component is 3. It's going 3 up. The component form of a vector combines the horizontal and vertical components, so the component form of the vector PQ is 5, 3. Now notice the way they've put that in these pointed brackets. So normally when we're doing a point on a graph, we use these rounded brackets, and we've got our x component and we've got our y component still. But when we do it this way, it's just a location on a graph. However, vectors have direction, okay? And so we use these arrows that are pointing in a direction to kind of indicate this is a vector. This is telling us to move in the direction of 5 forward, to move in the direction of up 3. So using this diagram, we're going to name the vector and then write it in its component form. So first our initial point is J, terminal point K, line, little arrow thing. So there's the vector JK. And we are going to say, now we need to find our XY components. So we've named it. Now we got to figure out how far forward it went. So it went 3 forward, so the X component is 3. And then it went up 4 places, so the Y component is 4. So we did the name, and we wrote it in component form. A transformation is a function that moves or changes the figure in some way to produce a figure called the image. Another name for the original figure is the pre-image. So this is a place where there can be some confusion. After you've transformed it, it's the image. Everything before you did a transformation is called the pre-image. The points on a pre-image are the inputs for the transformation, and the points on the image are the outputs. A translation will move every point of a figure the same distance in the same direction. More specifically, a translation maps or moves the points A, B, C of a plane figure along a vector xy. So notice how we've got each of these points, A, B, and C. All of them are being moved forward 2 and up 1. So the exact same transformation is happening. Notice how first we have B written normally, and then the transformed B has that little apostrophe mark after it. That, we call that prime. So this is B, and then it goes to B prime, A to A prime, C to C prime. Now those primes represent the images, whereas A, B, and C represent the pre-image. But the way we identify and tell them apart is by labeling the images with the prime. And if you then, well, we'll get to it. But there is something we do with prime if you then transform another transformation. Okay? All right, so we got the vertices of A, B, C are 0, 3 was A. B was 2, 4. And C is a 1, 0. And they want us to translate ABC using the vector 5, 1. So that would mean that each of them would have to go forward 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then down 1. And right there would be all of my new images. So, oops, mislabeled that one. So this will become A prime, B prime, C prime. Notice it's the exact same shape, just moved. So I have successfully performed that transformation. All right, next it wants us to write a rule for this transformation. Well, let's just figure out how one dot is going to the next. Now notice, over here in the red, we got the primes. So we must be starting with the blue triangle. That's our initial one. So A looks like it goes back 1, 2, 3, 4. So my X component must be backwards 4. And my Y component then went up 1 place. Now, those 2 points are going to be the same for each of them. We go backwards 4, up 1, backwards 4, and then up 1. All of them on there, all of those points did that exact same transformation. Now, that is us writing the component form, but they did say a rule. Now, there are a couple of other ways that we can write this. So, let's look at one. Another way to talk about or to write a rule is first we're going to write just a point and we're going to put X and Y in it. No numbers in there. But we're going to say that for any XY, it is going to become an X minus a 4. So you take all your X numbers, subtract 4 for them. And then to all your Y numbers, you'd add a 1 to them. So this is a rule that states what you're going to be doing to all your X and Y values. For example, A right here was a 4, 3. And if we follow this rule with all your X numbers minus 4, so 4 minus 4 would then be 0, and 3 plus 1 is 4. So that's how we got that point. So this is another way of writing the rule. So this is component form, or a vector. So I should say vector component form. This is what they are going to mean when they ask for the rule. Now, you're not going to be asked for the rule like this as much, but I want to make sure you're aware of different ways of writing it. So another way of writing this rule is we use a big T for translation, And then we put that vector component form just down here in little. So we transform it backwards 4 up 1. Okay. But this is probably how they're going to ask you to write the rule when you're working on your assignment. All right, next we need to graph the quadrilateral ABC with vertices. A at -1, 2. B is at -1, 5. C is at 4, 6. And D is at 4, 2. All right, and its image after the translation. Now notice they just gave us the components. So x plus 3, meaning that everything is going to move forward 3 places. And then we've got y minus 1, so then down 1. So that's forward 3, down 1. That'll be C prime. Okay, and then starting at D, forward 3, down 1. D prime. B, forward 3, down 1. There's the B prime. A, forward 3, down 1. And A prime. All right, and there's our translation based off of the rule, always going forward 3, down 1. All right, now let's talk about what a rigid motion is. A rigid motion is a transformation that's going to preserve the length and angle measure. So essentially, it's any way that you can move a figure that keeps the shape exactly the same. So all the sides are the same length, all the angles are the same angle. Okay, so notice how they moved, they translated this blue triangle there to the red. It's still the same triangle, therefore it's a rigid motion. And that's what the translation postulate states, is that a translation is a rigid motion. They do also give another word that a rigid motion is an isometry. Okay, when 2 or more transformations are combined to perform a single transformation, the result is what we call a composition of transformations. A composition being the combination of components. So combining components creates a composition. So when we do various translations, you'll notice here they did that translation, then they did another translation. So this up here represents the composition, the combining of different components. Okay. Now, if a single translation is a rigid motion, the composition theorem states that the composition of 2 or more rigid motions is itself a rigid motion. All right, so if I do one translation, which keeps the shape the same, and then I do a second translation, which also keeps the shape the same, then the combining of the 2 of them should represent a rigid motion. It keeps the shapes the same. So that's what we're going to do for this final problem right here. We are going to graph these points and then perform 2 translations. So first we've got -8, 5, and that is point R. And then -6, 8, and that's S. All right, so there is our pre-image. Now we're going to perform this translation, which has the x plus 5 and the y minus 2. So we're going to make sure to go with R forward 1, 2, 3, 4, 5, and then down 2. And there is R prime. And then with S, forward 1, 2, 3, 4, 5, down 2, and we have S prime. Okay, but they gave us a second translation. Now we're going to do this translation based off of the previous translation. This one says to go backwards 4 and down 2. So starting from R, 1, 2, 3, 4, down 2. Now what I'm going to do here is I'm going to do R double prime, showing 2 transformations have happened to this. Okay, S backwards 1, 2, 3, 4, down 2. Oops. And then that's S double prime. Okay, and so that's what I was talking about earlier, that if you perform multiple transformations, you can just keep adding primes to indicate how many transformations has happened. And in this way, we can also tell all of our R's apart. It's either R, R prime, or R double prime, and each of them is very specifically indicating 1 point. Okay, I hope this helps. Good luck.